Alrighty guys, so in today's lecture we're going to learn how to balance chemical equations. Now before we learn how to balance chemical equations, let's review what a chemical reaction is first. So at the end of this previous semester we were talking a lot about individual molecules, right? We were researching different organic compounds, learning about what they're made up of, what atoms are inside them, what they do to the human body, different functional groups. We're talking about individual molecules. But in this semester, we're going to be focusing a lot on what happens when these molecules they interact with each other, and that interaction is called a chemical reaction. So a chemical reaction, simply put, is a process where one or more chemicals change into one or more different chemicals. Okay, so basically you can have two chemicals that combine to form one different chemical. You might have one chemical that breaks down into three different chemicals, or you can have like two chemicals that kind of combine, mix around, and they form three different chemicals. Now, there's a lot of different combinations, but the idea is we have chemicals that become different chemicals, and that's what a chemical reaction is. Now, the way that we write chemical reactions or represent them typically are in things called chemical equations, and we talked about this before, but let's just review since it's been a while. In a chemical reaction, on the left side, we have the reactants. The left side is composed of the reactants, and the reactants are the starting materials. You can kind of think of them almost like ingredients when you're making a cake or some food. Whatever you start off with are called your reactants. So you have the reactants on the left side, and then you draw an arrow, and then on the right side you write the products, and the products are just kind of what the name says. It's what's produced, it's what's made. So you write down the chemicals you start with, you draw an arrow, and then you write the chemicals that you've made. And that's what a chemical equation looks like. So here we have an example of a chemical reaction right here, or chemical equation right here. On the left side we have H2. H2 is going to be one of the chemicals you start off with, plus Cl2. Okay, so these will be your reactants, what you start off with. And then you draw an arrow, and then on the right side you're going to write down what you make, which is your product. Okay, and we have a picture on the bottom to represent what these things mean. So H2 is a molecule that is made out of two hydrogen atoms, and they're stuck together. Okay, and then we have Cl2, which is made out of two chlorine atoms that are stuck together, and these will interact to make the molecule HCl. So H2 and Cl will interact with each other and create HCl. Now, what we're going to be talking about today is something called balancing. And so we're going to be learning what a balanced chemical equation is. A balanced chemical equation is a chemical equation that has the same number of each type of atom on both sides of the arrow. Okay, so let me repeat that. A balanced equation has the same number of each type of atom on both sides of the arrow. So what do I mean by that? So if you guys take a look at this equation, you're going to notice something kind of strange about it. If you notice, there are two H atoms, right, on the left side. On the left side, there are two H's. So I'm going to write two H's. And on the left side, there are also two Cl's, right? There's two chlorines. Okay, but if you look on the right side, I only have one H. I have one H. And I only have one Cl. One Cl. So this is what I mean by this equation being unbalanced. It's not balanced because there's more H's and more Cl's on the left side than there are on the right side. So is this a balanced equation? No, it's not balanced because there are more hydrogens and more chlorines on the left side than there is on the right side, on the reactant side instead of the product side. So what we have to do here is we need to add molecules into the reaction in order to get a balanced chemical equation. So let me show you guys how we're going to be doing that. So if you notice, there's one H and one Cl. But what we need to do is we need to make sure they're balanced out. We want to make sure that this gets to two H's, just like we have here, and this gets to two Cl's, just like we have on the left side, on the reactant side. We need the same number. So what do I have to do? I need to add one H, so I need to add one hydrogen, and I also need to add one chlorine. Now the thing is, you can't just do this. You can't just do, hey, I'm going to add an H and we're going to add a Cl. Because if you did that, what you would be doing is you would be adding different chemicals into the equation. You would be changing this reactant side into plus H plus Cl, right? Because we have HCl, we have H, and we have Cl. So you would be changing the reaction. Think of it as changing the recipe. You're basically changing the recipe that we're talking about. We're not talking about excuse me, this new reaction where it's HCl plus H plus Cl. We're talking about the reaction H2 plus Cl2 makes HCl. We don't want to add any new types of chemicals. What we have to do instead is we need to add what we already have. What we already have is HCl. So I'm going to be adding HCl. I'm going to add the same molecule that we already have to this product side. Now, let's do a recount of how many of each atom we have. So if you take a look on the left side, nothing's changed, right? So on the left side, we still have 2 hydrogens, right? Because we have H and H. And we also have 2 Cl's because we have Cl and Cl. And on the right side now, how many H's do we have? We have 1 H, 2 H. So we have 2 H's. And how many Cl's do we have? We have 2 Cl's. Okay, so now they're balanced because there's 2 H's on both sides and there's 2 Cl's on both sides. So we haven't changed the recipe, the equation, because it's still the same chemical, but there's a different number of HCl's. How many HCl's are there? There's 2 of them. So what we're going to do is we're going to write this as a balanced equation. What we have to do is we need to write H2 plus Cl2 makes 2 HCl. And this is the balanced equation. Okay, so what we did was we wrote this number in front of HCl. This number right here in the front is called a coefficient. You guys might have learned this in algebra, but this number is called a coefficient, and the coefficient tells you how many of that chemical you need in order to make sure this equation is balanced. Okay, and so we saw earlier why we need 2 HCl's. We need 2 different HCl molecules because we need to have a balanced equation. We need the same number of hydrogens and chlorines on both sides. Technically, you do have coefficients here. If you don't have a coefficient or a number in front of the molecules, it just means you have the coefficient 1. Okay, but in order to write a balanced equation, you don't need to write the 1s. If you don't write the 1, it's already assumed to be there. So this would be your balanced equation. Now I know in this problem we had some pictures, right? We had these ball pictures, but usually when we do balanced equation problems, you're going to have to use charts and numbers instead because you want to do it quickly. It's going to take time to draw all these molecules out. So let's do a quick example. Alrighty, so let's try another example, guys. So what we're going to have to do here is we're going to have to count how many of each element we have on both sides of the chemical reaction in order to figure out how to balance this out. So let's start with the left side. Which elements do you have on the left side? So let me start by drawing a dashed line to kind of show, hey, everything on the left side are going to be the reactants, and everything on the right side are going to be the products. This kind of shows us where we separate the two. So on the left side, what elements do we have? We're going to look for the capital letters because that's what represents the elements. We have H, so we have hydrogen, and we also have O, we have oxygen. Now let's count how many H's and how many O's we have. So if you take a look at the left side, the reactant side, we have 2 hydrogens. Okay. And then if you look for how many oxygens we also have 2 oxygens. So there we go. We have 2 hydrogens, 2 oxygen. Okay, but on the right side, how many hydrogens do we have? We have 2 hydrogens. How many oxygens do we have? We have 1 oxygen. So what this tells us is that, hey, there's an imbalance between the oxygens. There's 2 here, but there's only 1 here. So this chemical reaction is not balanced. So what we have to do is we need to add oxygens in order to make sure that these are balanced. Now we said we cannot do this. We can't just go into the problem and be like, hey, I'm going to add an O, and then I'm going to change this into 2, and then it's balanced. Because remember, if I add an O like this, what we're doing is we're changing the recipe. We're changing the molecules that are involved. We don't want to do that. We want to keep this exactly the same. So what I'm going to have to do is I'm going to have to add this molecule H2O in order to add another oxygen. Because if I add an H2O molecule, I'm adding another oxygen, right? And so I no longer have one oxygen. I have how many? I have 1, 2. I'm going to have 2 oxygens. And so now I have the same number of oxygens on the left side, the reactant side, and the product side. Okay, so the oxygens look balanced, but look at what happens when we add an H2O. We added 2 more hydrogens, right? We added this molecule, so what I did was I added another pair of hydrogens. So I added 2. So I no longer have 2 hydrogens on the product side. I have 4. I have 4. So what I did was I balanced out the oxygens, but I messed up the hydrogens. So what I'm going to have to do now is I'm going to have to go to the left side, the reactant side, and I'm going to have to add an H2 molecule. Because if I add an H2 molecule, I have 2, 4. So I no longer have 2 on the left side, I have 4. Now if you take a look at the elements, I have 4 hydrogens on both sides, and I have 2 oxygens on both sides. And now this is balanced out. So I need to write the numbers in front of my molecules. So I had an H2, but I have 2 of them now, right? I have 1, 2. So since I have 2 H2s, I'm going to write a 2 in the front. If you look, there's only 1 O2, so I'm going to write a 1. And there are 2 H2O, so I'm going to write a 2. So if I wanted to write this balanced equation out, this is what I would write on my paper. I would write 2H2 plus O2, because you can ignore the 1s. We don't have to write those out. And that produces 2H2O. So this would be your balanced equation. Okay? And this is your balanced equation because we have the same number of hydrogens and oxygens on both sides of the equation. So the math for this is not too difficult. It's really just adding. But it can get a little bit complicated, especially if you're not using this table. So I do recommend that you use a chart or a table like this. It'll be very helpful. Alright, let's move on to another example. Alright, so if you feel pretty confident trying these out on your own, you can feel free to do that. You can pause the video, but if not, that's okay. I'm going to go through it step by step. Now, so we have HGO produces Hg plus O2. So here, our line is right here. This is where we divide the reaction. On the left side, we have the reactants, and on the right side, we have the products. Okay, so let's count up how many of each element we have on both sides. On the left side, we have Hg and we have O. Okay, so we have Hg and O. Since there's no numbers behind them, we can just write 1 and 1. Okay? Now, if we go to the product side, how many Hg's do we have? We don't have a number behind it, so we just have Hg. So we have 1. How many O's do we have? We have 2. We have 2 oxygens. Okay, so if we notice, what is the imbalanced element? We have an imbalance in the, oops, not the Hg, I'm going crazy. We have an imbalance in the oxygens because we have 1 on this side and we have 2 on this side. There's an imbalance. So this chemical reaction is not balanced because we have more oxygens on the product side than we have on the reactant side. So what does that mean? That means we have to add another HGO to the left side. So I'm going to add the entire molecule to the left side. If I add another HGO to the left side, how many O's do I have now? I have 1, 2. I have 2 oxygens. How many Hg's do I have? I have 1, 2. I have 2 Hg's, 2 mercuries. So now our oxygens are good to go because there's 2 on both sides, but the problem is we have an imbalance in the Hg's now because I have more Hg's on the left side than the right side. So simple fix, I'm just going to go in, and since this Hg is just by itself, I'm going to add an Hg by itself. And that means I'm going to have 2 Hg. So I can put a 2 here because I have 2 HgOs, right? And I have 2 Hgs, so I'm going to add a 2. And since there's only one of these, one O2, I'm just going to write 1 for the O2. So my balanced equation, if I wrote it on my paper, would be 2 HgO, draw arrow, makes 2 Hg plus O2. And you can ignore the 1 because we don't need to write 1 if it's the coefficient. Okay, so this would be the balanced equation. Alrighty, let's do a couple more examples. So again, at any point, if you feel pretty confident trying these out on your own, you can pause the video, do it on your own. But again, I know this is new information, so I'm going to take it step by step with you guys. So here, I'm going to draw a line to separate the reactant side and the product side. And then we're going to count how many of each element we have. So if you take a look on the left side, what are the elements that we have? It looks like we have a C, we have a carbon. So I'm going to write that I have carbon. And it looks like there's no other carbons on the left side, right? So I'm just going to write 1. Okay, but we have, and we also have oxygen. So I have 1 oxygen here, but if you look on this molecule right here, how many oxygens do I have? I have 2. So that means I have 1 and 2, so that means I have 3 total. They're just split up between different molecules. Okay, so if I drew a picture of this, we would have like a C atom connected with an oxygen atom, and this would be CO. And then for O2, we would just have 2 oxygens stuck together, and that would be O2. So that would be like the visual representation of those molecules. If you notice, we have 3 oxygens, and then we have 1 carbon. Alrighty. So we counted up the elements on the reactant side, the left side. So let's count the ones on the product side now. On the product side, we also have C and O. Just so you guys know, you're always going to have the same elements on the left and the right side. The numbers are just going to be different. How many carbons do I have? I have 1 carbon because there's no number behind it. How many oxygens do I have? I have 2 oxygens. Okay, so we see here that the issue is going to be our oxygens. We have an imbalanced number of oxygens. Now, the easiest way to do this is just to add to the side that has less. So what we're going to do is we're going to add oxygen to the right side, the product side, because we have less, right? 2 is smaller than 3. So I'm going to add oxygens. The only way to add oxygens to the right side is by writing CO2. Now, if I add a CO2 molecule, my numbers are going to change a little bit. How many oxygens will I have if I add a CO2? I have 2 here, and I also have 2 here. So if I have 2 up here, and I have 2 down here, that means this I'm going to have 4. I'm going to have 4 oxygens on the product side. Now, let's take a look at the carbons. How many carbons do I have? I started with 1 right here, but now I have another 1. So that means I no longer have 1, I have 2. Okay, so I'm going to have 2. Okay, so when we do that, that kind of messes up everything, right? Because my oxygens are still not balanced. I have 3 on the reactant side, 4 on the product side, and I have 1 carbon on the reactant side and 2 carbons on the product side. So that kind of messed everything up. Now, if we take a look at the reactant side, we're going to have to add the molecules that we have there in order to balance it out. We have 2 different options. We can add more CO, or we can add more O2, but we need to be wise about which one we add, because if we add more of these, if we add another O2, that's only going to mess up our reaction more, because if I add an O2 here, how many O2s would I have? I'm going to have 4. Okay, so I'm going to have 4. But I wouldn't be fixing the carbons at all, right? And if I add another CO, then I would go from 4 to 5 and then to 2, and so it keeps messing things up. And so what we're going to do is we're going to try to be a little bit more wise and see if we can fix up the balancing in one go. Okay, so if you take a look at the difference between these two, right? Right now there's 1 carbon on the left side, and we have 2 on the right side. The difference here is 1 carbon, right? There's 1 more carbon on the right side. So as we go this way, it's going to be plus 1 carbon. If we look at the oxygens, as we go to the right side, it's going to be plus 1 oxygen. And so is there a way we can add carbon and oxygen at the same time so that we can balance this out? We can. If you look, we have a molecule that has 1 carbon and 1 oxygen. So if we add another CO, that's going to change up our numbers quite a bit. Okay, so if I add another CO molecule, if I add this, how many carbons do I have now? I have 1, 2. I have 2 carbons on the reactant side, so this becomes 2. How many oxygens do I have on the reactant side? I have 1, 2, and then I have 3, 4. So I have it in 3. I have 4 different oxygens, so I'm going to have 4. And now I'm going to be balanced out. Okay, so what we did was we added CO because CO can balance out both the carbons and the oxygens at the same time. So now we're ready to go. So we just need to put the coefficients in front of the molecules now. So we have 2 different COs, right? We have 1 here, so we have 2. We have 1 O2, and then we have 2 CO2s. So if I wanted to write this chemical reaction out, this balanced chemical reaction, I would write 2CO plus 1, I can ignore the 1, plus O2, sorry about that guys. Okay, you can just write the O2 because you don't need to write the coefficient if there's just a 1, produces 2CO2. So this would be your balanced chemical equation. Alrighty, we'll do one last example, and this one's going to be probably the hardest one that we've done. But I think you guys can do it, so feel free to pause the video and try it out on your own. Okay, so we have this big thing right here. So this this looks very confusing because we have a lot of different elements. We even have a parentheses, and I know some of you guys might not even remember what the parentheses mean, but it's okay. We'll try it out. But again, if you feel confident, feel free to pause the video, try it on your own. But if not, I'm going to go over the answer right now. So what I'm going to do is I'm going to draw a line down the middle just so that we can separate the reactant side and the product side. Okay, so I'm going to write reactants here. And then we're going to have the product here. So first thing that we have to do is we need to count up all of the elements. So let's count the elements. So we have to start off, we have Cu, we have copper. Remember, the capital letters is the start of the new element. So we have copper. And if you look through, we don't have any more Cus. We have C, but that's different from Cu. So we have 1 Cu. Okay, we also have an S, and we only have 1 S because I don't see any numbers behind it or any other S's. How many O's do I have? I have 4 O's. I have a K, I have a C, and I have an N. So I have 1 K, I have 1 C, and I have 1 N. Okay, so we have 6 different elements in this reaction. Now we know that if we have CSO, KCN, we don't even need to look at what's on this side. We know that we're going to have a Cu, we're going to have an S, we're going to have an O, we're going to have a K, we're going to have a C, and we're going to have an N. Because if it's a balanced equation, we're going to have the same types of elements on both sides of the equation. Let me write the Cu because that came out kind of ugly. Okay, so what we just need to do is go through this product side, this right side, and count up how many of each element we have. Now, let's start with the Cu. How many Cus do I have? It doesn't look like there's a number here, so that means I only have 1 Cu. And it doesn't look like we have a Cu in this molecule either. So I have 1 Cu. Now, we have this parentheses right here. What this parentheses means is that the number on the outside is going to multiply by everything on the inside. So what that means is if you take a look just inside the parentheses, so let me write this out a little bit bigger. So we have parentheses CN2. if you look at C, there's no number behind C. That means it's the number 1. So that, and N, there's no number behind the N, so that means it's also the number 1. What we're going to do is we're just going to multiply everything on the inside by the number on the outside. So there's 1 carbon inside the parentheses, but there's a 2 on the outside, so I'm going to have 2 carbons. And then for the N, it's a 1, but there's a 2 on the outside the parentheses, so it's going to be 2 nitrogen. So hopefully that rings a bell from when we learned about the parentheses and how to count elements like that. Okay, how many K's do I have on the right side? I have 2 K's. How many S's do I have? I have 1 S. And how many O's do I have? I have 4 O's. So let's take a look at the ones that are not balanced out. So the Cu is balanced out, the S is balanced, the O is balanced, but the thing that's not balanced are the K's. The K is not balanced out, the C is not balanced, and the N is not balanced. So how can we balance this out? If we go back, we want to add to the side that has less. So this side has fewer KC and N, right? There's more KCN on the right side. So what we're going to want to do is we're going to have to add KCN onto the left side, the reactant side. Lucky for us, they're all in one molecule, so we can add KCN. If we add a KCN, how many Ks am I going to have? I'm going to have 2 Ks. So I can change this to 2. How many C's do I have? I have 2 C's. And we kind of get the pattern, right? How many N's do I have? I'm going to have 2 N's. So I'm going to have 2 N's. And so if you notice, we are all balanced out and ready to go. We have the same number of Cu's, 1 and 1. We have the same number of S's, 1 and 1. We have the same number of O's, 4 and 4. We have the same number of K's, 2 and 2. We have the same number of C's, 2 and 2. And we have the same number of N's, 2 and 2. Okay, so now we can just put the numbers in front of the molecules. So let's do that. Okay, how many SO4s do we have? We don't have anything added, so we just have 1. How many KCNs do I have? I added another 1, so I have 1, 2. So I'm gonna put a 2 in the front. How many of these do I have? I have 1. How many of these do I have? I have 1. And so if we wanted to write the balanced equation for this on our paper, we would just write CuSO4 plus 2 KCN, because we need to write the coefficient, produces Cu parentheses Cn parentheses 2 plus K2SO4. And there you go. That is going to be your balanced equation. And the only molecule to have a coefficient is going to be KCN, because it's the only one that you have more than one of. Alrighty guys, so hopefully that was helpful. If you guys have any questions, I am on the Zoom call, so make sure you guys let me know. Good luck on your assignment, and we'll see you guys next time.